Hello guys, welcome to Explore, and this is Visalakshi. So in this video we are going to discuss about structure of atom. It is very interesting lesson actually, and you can visualize an animative electromagnetic wave in this video. I know you are very excited, but before that let's go for wave nature of light. I am going to explain this topic through two different applications. So let's go. First, let's assume a pond and now throw a stone into the pond. And now we observe ripples in the water. So these ripples are transmitting disturbance in the form of waves on the surface of water. The same way, light is transmitted in the form of electromagnetic waves. Now let's go for second application. You recognize the sound? Yes, this is the drum roll. Sound is produced only after the vibration of the upper part of a drum. That means we vibrate the upper part of the drum to produce sound. In the same way, electromagnetic waves are produced when an electric charge vibrates. Vibration of charge produces an electromagnetic wave. A vibrating electric charge creates a change in electric field, and the changing electric field creates a change in the magnetic field. We observe that the electric field and magnetic field are both perpendicular, and this red color wave is electric field and this is magnetic field. So the distance between the two peaks of the waves is known as wavelength. The distance between the peaks of two waves is known as wavelength. Finally, an electromagnetic wave travels like this. This is how an electromagnetic wave looks like. I think you have got a perfect idea about electromagnetic wave. So, electromagnetic waves have a wide range of wavelengths of gamma rays at the shorter wavelength to radio waves at longer wavelengths. But our eyes are only sensitive to visible light. So, these electromagnetic waves have a wide range of wavelengths. This entire range of wavelengths is known as electromagnetic spectrum. Now, let's have a look at visible spectrum. I think you have already seen this visible spectrum, a beautiful rainbow. Each color in a rainbow is characterized by a specific wavelength from red to violet. These colors, these or violet, indigo, blue, green, yellow, orange, red, that the human is sensitive to are called visible light. The range of wavelengths covering from red color to violet color is called visible spectrum. Now, let's go for an experiment to know more about our visible spectrum. So, take an iron rod and heat it. Some of its heat energy is emitted as light. First, it turns into red. That means lower energy corresponding to higher wavelength. It requires higher energy, but red is of higher wavelength. And if we heat more, it glows into orange and yellow and blue. It means it requires higher energy and it's of lower wavelength. And if we heat in more and more temperature, it may be turned to white also, but it requires a lot of temperature. So what we conclude from this experiment? We conclude that the amount of heat energy that was observed by the iron rod is emitted as light. It means the iron rod absorbs some energy and this energy is emitted as light. And as the temperature increases, the amount of heat absorbed by the iron rod also increases. So it shows different colors according to its corresponding wavelengths. Let's go for Planck's theory. According to Planck, electromagnetic energy can be gained or lost in discrete values and not in continuous manner. It means according to the Planck, the energy emitted is equal to an integral multiple of h mu. Here, this Planck's theory can be represented by this equation where E is equal to energy and h is nothing but Planck's constant and mu is nothing but frequency. And this is Planck's theory, and thank you for watching. Don't forget to like, share and subscribe.